change of variables in multiple integrals. This is the formula for calculating change of variables. So we're gonna utilize this formula. This is simply the Jacobian transformation of sy with respect to uv. So let's take a look at an example. We are given this double integral. We have to evaluate it, where r is the parallelogram by the lines x minus 2y equals 0 and this 3x minus y equals to 1 and this. So solution. We are going to use this formula to consider this. So let u equals x minus 2y. U equals to x minus 2y. So that u equals to x minus 2y and v equals 3x minus y. Clearly, from what we are given, x minus 2y equals 0 and x minus 2y equals 4, which implies u equals 0 and u equals 4. That is, u lies between 0 and 4. The same thing with v equals to 3 minus y. We have 3 minus y equals to 1. 3x minus y equals to 8. So v equals to 1 and v equals to 8. Which implies v equals to 1 and v equals to 8. That is, v lies between 1 and 8. So we are going to use these values to this and this to evaluate our integral. It will be our limits of integration. The next thing to do is to calculate the Jacobian. So we are going to calculate the Jacobian using this formula. A Jacobian transformation of sy with respect to uv is simply partial s, partial u, partial s, partial v, and partial y, partial u, partial y, partial v. So the next thing to do is to express s in terms of u and v, and also express y in terms of u and v, so that we can simply differentiate our partial derivatives. Let's call this equation 1 and this equation 2. So from 1 we can make x the subject of the formula, in which we can write s equals to u plus 2y. Let's call this equation 3. Substituting this value into equation 2, we obtain v equals 3 into u plus 2y minus y. If we open this guy, we have 3u plus 6y minus y, in which we have 3u plus 5y equals v. Making y the subject of formula, we have y equals v minus 3u over 5. So we can now differentiate with respect to v. We have 1 over 5, and with respect to u, we have minus 3 over 5. We are going to do the same thing for x. So from this equation 2, we have y equals 3s minus v. When this guy goes here and this guy comes here, we have y equals 3s minus v. So let's call this equation 4. Substitute equation 4 into 1 now. So we obtain u equals s minus 2 into 3s minus v. So that we have u equals s minus 6x plus 2v. So that we have u equals minus 5s plus 2v, which implies 5s equals 2v minus u, which which also implies 1 over 5 into 2v minus u. You can differentiate this guy with respect to v. So we have 2 over 5. With respect to u, we have minus 1 over 5. We can now plug in our values into our Jacobian transformation. So we have for partial s partial u, we have minus 1 over 5. So we have minus 1 over 5. Partial s partial v, we have 2 over 5. Partial u, we have 1 over 5 and minus 3 over 5. We can now evaluate our Jacobian. This is 3 over 25 minus 2 over 25, which is 1 over 25. It's an error here. Partial u is minus 3 over 5, so we have minus 3 over 5. This guy will be 1 over 5. So when we do the multiplication, we have minus 1 over 25, and this will be minus 6. Will be minus 6 over 25. So 6 over 25 minus 1 over 25, we obtain 5 over 25, in which we have 1 over 5. So that's our Jacobian. Now we can now evaluate our integral and substitute our Jacobian transformation into it. So doing so, we have let me write it here. We have double integral for u, we have 0 to 4, 0 to 4, and for v we have 1 to 8, 1 to 8. So here, s minus 2y, we have replaced it with u and the denominator by v, so we have u over v. So we have u over v times our Jacobian transformation, which we obtain, which is 1 over 5. So we have 1 over 5 times dv du. So we differentiate with respect to v. This is constant, and we are going to fix u because we have to differentiate with respect to v first. So we have 0 to 4. When we differentiate with respect to, we integrate with respect to v, rather, we have ln v u over 5, evaluating from 1 to 8 du. Plug in 8 for v here and 1 for v, so we have u over 5 ln 8 minus ln 1 du. Don't forget our integration. So this is 5 ln 8 minus ln 1. Ln 1 is simply 0, so we are left with u over 5 ln 8 du. And we take ln 8 out, we have ln 8 and over 5 out, we have 0 to 4 u du. Because these are constants, you can take them out of the integral. So we have ln 8 over 5. Integrating this, we have u square over 2, 0 to 4. So we plug in for here, we have 16 over 2 and ln 8 over 5. So this guy, we have 1, we have 8. So we have 8 ln 8 over 5, which is our final answer. So when we evaluate this integral, this double integral, the quotient of this guy, s minus 2y over 3 over s minus y, where r is the parallelogram enclosed by the line, this. So the final answer is 8 ln 8 over 5. Thanks for watching.